Preparedness Month. So this is the 2024 version of Skywarn training. I like to start each Skywarn training with some pictures of some recent events. And the hailstone that you see there on the far left was taken from Round Rock, Texas, last September 24th, 2023, with a very large hailstorm that came right down Interstate 35, caused well over $300 million of damage in Williamson County and also $300 million of damage in Travis County. The picture in the middle there, we'll actually have a video of it in our tornado section, is a weak tornado that went through San Antonio back last October 26th of last year. It was an EF0 tornado, and we'll talk a little bit more about that event when we proceed through the training. And then finally, in the far right, there's a QR code. We will revisit this QR code at the very end. When you go to that QR code, you'll actually get our 1-800 number that I'll actually have on a couple of slides elsewhere. So again, if you like the QR code kind of a thing, you can do it now. But also, we'll have it at the very, very end. So what is Skywarn? Skywarn equates basically to storm spotters. We have a bunch of great tools at our disposal: satellites, Doppler radars, weather models, observation sites, mainly at airports. But a lot of those things, especially the radar and the satellite, of course, do not tell us what's actually happening at the ground level. So thus, we are in need of people to basically tell us what they are seeing. Maybe that's the size of hail that's falling. Maybe that's the wind damage that maybe just occurred with a severe thunderstorm. But it does come down to providing us situational awareness and ground truth. This Skywarn training has been going on for decades, and for the most part, in the very beginning stages, it was actually toward amateur radio operators. We still have a lot of amateur radio that listed in onto these sort of trainings, attend in-person trainings as well. But it's expanded way more than that, especially to general public. We do not teach storm chasing, and we do not encourage our spotters to go mobile and go to certain areas or to chase down sort of thunderstorms. We want you to do this safely. We want you to kind of stay put where you are and see what you observe, and then call that in if it meets the criteria that we'll talk about toward the end. So in Texas, we've had about 1,000 people die in weather-related incidents since 1990. And as you can see, flooding makes up a large chunk of that, followed probably second with cold and heat events, and then also tornadoes. And then you can see a lot of the other different sort of weather events that kind of fall in behind that. And yes, we have had a death in Texas from falling hail before. So there's been a definite decrease in tornado deaths over the past several decades, which is good. But unfortunately, especially when it rains a lot in Texas, the flooding is significant. And we typically have a lot of fatalities that follow from that. The mission of the National Weather Service is protection of life and property. So a couple of images that you see on the screen on the top right is our operations area several years ago during Hurricane Harvey, where the operations area was very, very busy. On a typical calm weather day, like we had over the last couple of weeks here, very few people, only about 2 people on shift per shift. We are 24/7 operations, but as you can imagine, as the weather gets interesting, as the weather gets more significant, the phones start ringing, more products go out, watches and warnings get issued, a lot of back and forth with emergency managers. So it just becomes a lot more of a workload issue. And so we call in extra people on days off, previous shifts, stay over, etc., to basically get all the workload done. It does take a huge partnership between us and the emergency management of cities and counties, the television media, the radio media, social media, first responders, amateur radio, and even the general public. So there's a lot of pieces to the puzzle, and to make the watch and warning program of the National Weather Service and the government in general, we need buy-in from the general public. And this is, taking this sort of training is a great way to buy in and to be part of the process. The National Weather Service, the federal agency that I work for, is housed under the Department of Commerce. And then an agency within the Department of Commerce is NOAA. And then the National Weather Service is an agency within NOAA. So what you see on the screen are 122 field offices that make up the field office map of the National Weather Service. We have an office in Guam, we have an office in Hawaii, we have one in Puerto Rico, and we have 3 in Alaska. and all the others are actually in the lower 48. So just in Texas alone, we have 13 offices that handle the 254 counties of Texas. All these offices that you are seeing on the map are 24/7 operations, rotating shift work, trying to keep everybody safe and trying to let everybody know what's going on weather-wise. A zoom-in view of our jurisdiction here at the New Braunfels, Texas office, which we also call the Austin, San Antonio office. You'll see the 33 counties go from the far west out there by Valverde and Maverick County, which is where Del Rio and Eagle Pass are, stretches across the hill country into the Interstate 35 corridor, the areas between Georgetown, Austin, and San Antonio, and then extending as far east as LaGrange, Shiner, Hallettsville, out there in Fayette and Lavaca County. So we have the coastal plains of Texas, we have the Interstate 35 corridor, we have the hill country, we have the Edwards Plateau, and the Rio Grande Plains going all the way out to the Rio Grande River. Our jurisdiction is 36,000 square miles. That's roughly the size of the state of Maine. And as far as what we do for these 33 counties, we produce the forecast, 7-day forecast every hour, or hourly, I guess I'll say. We produce the weather watches and warnings. We do a lot of decision support to emergency management coordinators, or what we call EMCs. Every county in the state of Texas, the county judge actually is the emergency management director, and they typically will hire an emergency management coordinator. So we do a lot of back and forth decision-making support for those sort of folks, and do a lot of local research and outreach as well. So beyond just the watches and warnings that we issue, we also issue advisories. So the advisories most commonly are things for, I would say, nuisance type of weather events. A flood advisory may be issued in an urban area for 1 to 2 inches of heavy rain that fall in a short amount of time. So those favored roads that are flood prone in cities, and maybe even low water crossings that are flood prone out in the rural areas get flooded. And so that would be a flood advisory sort of issuance. A dense fog, wind can be advisories as well. Obviously, you have impacts to travel, takes you longer to get to work, have to really slow down on the roads, that sort of thing. If we actually have a lot more impactful weather approaching, or we think will be significant, maybe even loss of life, then that's where a weather watch will be issued. Watches are typically in groups of counties, many of them kind of grouped together because that's where we think that all the ingredients are coming together for this possible sort of weather event. So examples on the very top there in green counties are the ones that were in a flood watch. Down below in the blue, that was a severe thunderstorm watch issued by the Storm Prediction Center. So it doesn't mean that everybody in those colored in counties are going to see that particular weather event. It just means that that's where all the ingredients are taking shape to where the possibilities are going to be there. And the very most significant product that we actually issue is the weather warning. It could be a tornado warning, a flash flood warning, a winter storm warning. It basically means to seek shelter now or follow the advice of the warning. In cases of flooding, maybe that means move to higher ground. But these are imminent threat sort of products, meaning that we've already seen that weather threat or it is imminent. In the case of, let's say, like a tornado warning. Sometimes the tornado warnings are issued because someone sees the actual tornado, or it's because it's an imminent threat that we see it developing on our Doppler radar. There are two types of warnings that we can issue where we can put the word emergency in front of it. And that becomes then a flash flood emergency warning and a tornado emergency warning. What that term emergency means is that we are expecting catastrophic damage and loss of life. In South Central Texas, where we are, we have had to issue several flash flood emergencies in the past. 2015 was a very, very busy year with that sort of flooding along the Wimberley area. That's the image that you see on the far left was the Blanco River there, just upstream of Wimberley, and the damage and destruction that you kind of see. As far as tornado emergencies go, these are typically saved for a very strong to powerful tornado. We can sometimes tell that by radar. Sometimes we tell it more about the type of damage that we're actually getting. But you know, when you have a warning with the term emergency in it, especially the television folks, they will know to basically go to wall-to-wall coverage. And so it leads to a lot more information kind of going out to the general public. and for people to basically be, you know, there's no more break-ins. They're on the news, and they're basically throughout the event kind of handling that and passing along really good information, being the megaphone basically to the National Weather Service. So does not happen very often. During one of our past events that we just had, Hurricane Helene in the southeast United States, there were a lot of flash flood emergencies being issued, and there's a lot of loss of life because of that particular event. When it comes to some of our definitions, we want to specifically talk about the definition of a severe thunderstorm. In our world, in the National Weather Service world, a severe thunderstorm is a thunderstorm that produces at least 1-inch diameter hail or the size of a quarter, damaging winds with wind gusts or sustained winds in excess of 58 miles per hour, and or a tornado that is in contact with the ground. So lightning is not included in the definition. You can have a thunderstorm with a very, very high amount of lightning, very prevalent, but that technically doesn't make it a severe thunderstorm. It just makes it a thunderstorm with a lot of lightning in it. So when we're issuing severe thunderstorm warnings, these are the criteria that we are issuing them to. So let's talk about the country in general and where significant severe weather occurs. This is a combination map that shows not only tornado watches, but severe thunderstorm watches over a 20-year period. So basically, where are all those severe thunderstorm and tornado watches issued across the United States? As you can imagine, middle part of the country is very active. You see those portions of Oklahoma, a lot of the counties there average more than 20 different severe weather watches per year. Notice the West Coast is rather quiet. The cold ocean waters, the Pacific, keep it very stable, so they do not get a lot of thunderstorms out over the West Coast. They have some in the Rocky Mountains, but primarily where it is hot and humid, especially in the warm season months, is typically where we have a lot of the weather watches. If we section out just severe thunderstorm watches, again, middle part of the country is where we have a lot of the severe thunderstorm watches. Where we are in our portions of Texas, a lot of our counties kind of average anywhere from just shy of a dozen to somewhere between basically 5 and 10 sort of severe thunderstorm watches per season. Now, if we switch over just to tornado watches, look how it shifts down to the southeast United States. Again, in our portion of Texas, those lighter colors of blue, we average about 1, 2, or 3 tornado watches per year, while areas in the southeast United States, places of Alabama, Florida Panhandle, Mississippi, Louisiana, Arkansas, will average, in some cases, sometimes over a dozen tornado watches per year. There's a couple of reasons for this. That has become a very active area with very, very strong severe thunderstorms over the last couple of decades. We can now call it Dixie Alley. But when we have landfalling tropical systems, that also induces tornadoes. And so if you have several decades worth of landfalling tropical systems in the northern Gulf, you will have had a lot of tornado watches being issued because of those tropical events. And so that's kind of why, especially in this map between 2004 and 2023, there's so much of a bullseye, I think, down there in the southeast United States. Obviously, the middle part of the country is very active with tornadoes, but over the last couple of decades, the southeast has been the most active. We get some guidance from our Storm Prediction Center. That is a group of National Weather Service meteorologists in Norman, Oklahoma. They are the severe weather experts. So they will give us, the field office's, guidance on where they think we will have the most significant of severe weather, how widespread it is, and what type of events we will actually have. So the map that you see is from March 21st, 2022, where the city of Austin, all the way down almost to New Braunfels here, we're in a moderate risk. We're a category 4 of risk area. That is very rare for us. The last time we had been put under a moderate risk was nearly 10 years prior. So for us, it was a big red flag that there was a very high chance of getting severe thunderstorms, and some of those would be very significant with tornadoes, etc. The most common severe weather day that we have in this portion of Texas, a lot of times will be in levels 1, 2, and 3, or marginal, slight, or enhanced risk. It is extremely rare for us to be in a high risk or a level 5, that pinkish color. Typically, 1 or 2 places in the country per spring will be in a high risk. That's where a lot of the storm chasers will gather. and there's a lot of long track damaging catastrophic sort of tornadoes. The last time that this area of South Central Texas was under a high risk was actually back in 2007. Everybody should have at least 3 ways of getting weather warnings to you. You need redundancy in getting warnings. So yes, most everybody kind of uses cell phones, and they have their favorite apps that they get maybe warnings sent to them. Make sure you have a couple of them in case there are issues with the app. Make sure you have ways of getting weather warnings without a cell phone. So the old-fashioned NOAA weather radio is still working. It's been around for decades and decades. VHF radio, you can get them pretty cheap, less than 30 or 40 bucks typically. And they're basically your own personal tornado siren for your house. The FEMA app is a really, really good app to download onto your phone. You can save 5 locations, and you can choose which weather warnings you'll actually be getting. All National Weather Service offices have social media. Now, for the folks here in South Central Texas, and again, I'm going to be prefacing that most of the information I'm going to be giving today is about South Central Texas. So if you're listening to this outside of this region, just know that where you are, you may actually have some different type of threats and different ways of reporting. So just be aware of that. I'll mention that again when we get to our special reporting phone number. But every National Weather Service office in the country have their own social media accounts. Ours are tagged as NWS San Antonio. So we are on X, Facebook, we have a YouTube channel, we also have Instagram. So if you'd like to follow us, I would say please do. We also get some support from what we call a virtual operations support team, or a VOS team. These are volunteers for us that are very good in social media. They have good followings, and they also have very good weather sense. And so what they will do, they will be our megaphone on social media. They will do a great job of retweeting and resending out information about severe weather or any sort of other sort of weather incident we have, but then also be combing social media for us and then sending reports to us that they are seeing on social media. Maybe somebody has taken a picture of some large hail or of some damaging wind that has occurred. We don't have enough staff usually to just start combing through just all different social media accounts, especially if the weather is very active. So these folks in these different VOS groups will help do that and then pass along that information to us, just to speed up the process and let us know what's happening out there. Of course, we would love to always have storm spotters call us. A lot of storm spotters forget to call us. They'll post things on social media, but nowadays with social media and cameras on cell phones, we get the majority of our reports actually from the general public. A lot of folks will actually get warnings sent directly to their cell phones without signing up for anything. We call those wireless emergency alerts. And the way that works is that if we are at our office and we issue a particular warning, as an example, a tornado warning, we are drawing a box for where that warning will be. Basically drawing the box of where everybody in that box, citizen-wise, is going to be in danger. Well, that box that we drew actually gets sent to the cell phone carriers, like a Verizon, AT&T, and Sprint, not Sprint, T-Mobile, all the different carriers, and they will see where the box lies in relation to their cell phone towers. If they have cell phone towers within the warning box that the National Weather Service drew, they will send a text to every user that is using data from that particular cell phone tower. So what's great about this sort of process is that if you're traveling somewhere and you don't know the name of the town that you're driving through, or you don't know the name of the county that you're driving through, if you get that text on your phone, that means you are within that warning box. The different products that alert your phone in this way are tornado warnings, flash flood warnings, some severe thunderstorm warnings, the ones that we have a destructive tag, meaning baseball-sized hail or 80-mile-per-hour winds, hurricane warnings, storm surge warnings, extreme wind warnings, which come from hurricanes, tsunami warnings, dust storm warnings, and then finally snow squall warnings. So obviously some of these, like a snow squall warning, we will likely never be activated here in South Central Texas. I hope not. And of course, if you don't live along the coast, then you may not be under a storm surge warning ever. But if you are traveling, or if you do live by the coast, just know that these are some of the warnings that will come directly to your phone automatically. When you buy a new cell phone, these alerts are actually turned on. And on this is a screen capture of my iPhone, And you can see that under the settings and the notifications menu, at the very bottom, there's something called government alerts. And the emergency alerts are the weather ones. And public safety alerts are ones that can come from your local city or county emergency management office in case there's a local emergency that may be not weather related. An example of that would be like a hazmat incident where something spills from a 18-wheeler and they have to evacuate a large section or maybe in a small section of the city. Okay, so enough for that beginning. What we're going to do now is talk about some of the thunderstorm hazards. We're going to start off with lightning. We'll continue in through flash flooding. We'll go to hail, thunderstorm winds, and then finally tornadoes. So first, facts about lightning. 50,000 degrees hot, 30,000 amps, and roughly 100 million volts. Those are averages for a typical sort of lightning strike. There are some lightning strikes that are much more powerful than that, and there are some that are much more weaker than that. All of them can cause fatalities. And in fact, last year we had 14 fatalities across the United States. We're a little bit below that number right now in this current year, which is good. We like to have low numbers, obviously, with lightning fatalities and all weather fatalities. But the trend has been for them to be fairly low over recent years, which I'll show. The most common way that folks get hit by lightning or sometimes even get killed by lightning are from bolts out of the blue. Now, blue skies do not cause lightning. Thunderstorms cause lightning. But sometimes if it comes from out and on the side of the thunderstorm, you can literally have blue sky above you. In these two images on the screen, it is not raining where those lightning bolts are actually hitting the ground. So that's the big danger. It can strike up to 10 miles away from the parent thunderstorm. This is a review of lightning fatalities from last year in 2023. We had 4 in Florida, 2 in Texas, and then several other states had a fatality in them. You can see the numbers of fatalities ranging from 2017, we had 16 fatalities, to even in 2022, we had 19 fatalities. So basically averaging less than 20 folks per year. If I would show this kind of the same map 30 or 40 years ago, we were averaging upwards of 30, 40, maybe even 50 people getting killed from lightning every year. So the numbers are significantly lower from where they were decades ago. On the bottom there are what people were doing last year when they were known to get struck and killed by lightning. The ones in dark blue are males. The ones that are highlighted in a lighter blue color are females. And you can just kind of look at the locations and activity. The one that is mentioning driving a car, they were killed as the tree fell on the car. The car typically is actually a safe haven. The metal frame of your car protects you like a Faraday cage. But if you're outside just walking, or if you're underneath a tree, or in the parking lot, in the driveway, or on a lake on the boat, you can see those are all things that where someone was killed. There was even someone killed while on a horse checking on cattle. So all very, very sad cases, but typically mostly preventable if you are not outdoors when it is thundering outside. Trees are not shelters. This is a small little video clip kind of showing how a tree can explode as that really powerful hit of lightning with all of that heat can turn the moisture to steam inside a trunk, expand, and then the trunk will sometimes explode. So a lot of softwood trees will typically have this sort of reaction to a direct hit by a lightning strike. So one of the worst places to be with lightning is standing underneath a tree. Yet we still see it all the time, people seeking shelter underneath trees. There's another video clip of lightning hitting looks like a large pine tree. You can see some cattle that have died while standing underneath the tree. And in the far top right, there is an image from the 2019 FedEx Cup PGA golfing event. You can see some people on the right-hand side down on the ground tending to people. These were people that were struck by lightning. And even on that tree, you can see the scar where the bark was blown off that pine tree trunk. So nobody died in this incident, but people were, I believe they were in cardiac arrest. That's the typical thing that happens. All that big shock of energy hitting your body will a lot of times stop your heart. But notice the tree in the background. Even though someone just got struck by lightning and the tree got hit, there are still people standing underneath another tree. So when you ever go out to locations, let's say it's a festival, it's a concert outdoors, you should always have some sort of place in mind to go where you kind of know where should you go in case there is thunder or in case there's a thunderstorm coming. Many times when you go to these very, very large gatherings, they technically don't have enough space to shelter everybody. So you do have to become your own person here and kind of really think about where should you go in case you're watching a radar app and you see a thunderstorm coming. Because a lot of times, even though they may have plans on what to do, it takes a long time to activate those plans. When it comes to fatalities by gender, males dominate. 80% of the nearly 500 people that have died since 2006 from lightning, 80% have been males and 20% females. For the day of the week, may not be surprising to most of you, since lightning tends to be an outdoor sort of an event. You can imagine that the majority of the fatalities happen on days of the week where a lot of people are outdoors, and particularly Saturday. And the least amount of fatalities have actually happened on a Monday. By activity, 62% of those nearly 500 cases were people doing fun things outside. We have a slogan called "When Thunder Wars Go Indoors." It's the best way to keep yourself safe. If you hear thunder outside, you should be indoors. When I was younger, they had a 30-second rule where you would see the lightning flash, you would count to 30. If the thunder happened before you hit 30 seconds, then yeah, it was close enough that you should be inside. We've much more simplified that to just if you're hearing thunder, you should be going indoors. And of all those leisure activities, water-related activities kind of lead that, along with sports as a second. So if we kind of ask people what kind of sports are people getting killed from lightning, most people will obviously probably say golf because historically that's what you always heard, right? Soccer, though, out of the 40 cases where people were playing some sort of sport and they got killed from lightning, running, golf, and soccer all kind of lead the most. Anywhere you're on an open field where you are an actual tall object at that point is a good thing to kind of keep in mind. Okay, we're switching over to flash flooding. We've seen a lot of video over the past several days from Hurricane Helene, as it went into the Asheville area, the mountainous area, the hilly areas of Appalachia, western North Carolina, and South Carolina. The terrain here in our hill country is not much different, and thus we have also had very historic sort of flash flood events, much like kind of what you're seeing this past week. It is the #1 storm-related killer on average across the United States. We are known to be living in Flash Flood Alley, this section of Texas, which has a perfect combination of bad soil types, because we're on limestone rock here, versus the urbanization of the I-35 corridor and the terrain itself, just the hills. You put all of that together, you don't have too many other areas in the country that have that perfect combination. And so we do have the most flash flood fatalities in all of the country if you go back several decades. This is kind of a view of our jurisdiction here in South Central Texas with the county names listed, as well as a number underneath that county name. Those numbers are people that have perished and have died in flooding and flash flooding events. Bexar County has the most of 34 people that have gone. Travis County behind that at 23. There's 160 deaths that have occurred over the past 27 years just with flash flooding. Notice there are some counties with 0. They do get heavy rain in those counties, but it's also particularly flat in those particular counties. And so if the county is flat mostly, does not have a lot of terrain, that tends to have the water moving slower. Slowing water or slower water than compared to the hill country allows you to get out of its way. You can wade through some waist deep water if it's not moving very fast and get to higher ground. But it's the fast moving water in the hill country and the urban areas that really set the stage for most of these fatalities, which tend to be all vehicle related and tend to be at nighttime as well. Some of the few on the numbers on the map there that are not that sort of case are especially like in Hays County during the Wimberley event, where we had 9 fatalities in one house alone. That was, however, a nighttime event. There are a couple of situational awareness websites that you can go to, especially if you live in around the Austin area and the San Antonio Bexar County area. Those are on the screen there, atxfloods.com, as well as bearflood.org. Both of those websites have low water crossings that are flooded. And as low water crossings become flooded, they will turn red. So if you are thinking about going out traveling, if you need to run some errands, and we've had a lot of heavy rain in the area, these are two websites where you can go, atxfloods.com and bearflood.org, to kind of check to see what kind of road conditions are out there as well. A great way to kind of remember how strong water is and how it can push your cars off the road is what I call the 6-12-24 rule. 6 inches of fast-moving water can knock a person off their feet if the water is moving very quickly. 12 inches of fast-moving water can sweep a small car off the road. And 18 to 24 inches of fast-moving water can carry away most large SUVs, vans, and pickup trucks. The faster the water is moving, the easier it is for that vehicle or that person to leave the roadway. And especially, like I mentioned, if this is happening at nighttime, then it just adds a whole other issue of trying to get rescued, trying to find you, how far downstream you get pushed. It's all of that. So the best advice, obviously, is turn around, don't drown. Never get yourself in a predicament where it's you versus the physics and the equation of whether or not your car is going to leave the road. People take chances. They make really, really bad and poor decisions. If you see a low water crossing flooded, just simply turn around and go a different direction. Some folks don't want to get bothered by that. They don't want to find a different route. They don't want to take another 30 minutes to get on that other route to get home. So they'll take some chances. And that's typically when they lose out. The case there on the far left is that is Spicewood Springs Road in Northwest Austin. While the water was shallow over the road, what they didn't realize is that the fast flow of water actually swept that road away. And so there was a big gully there. There's a big hole basically in the roadway. And that's where the car got stuck. 1 foot of water can displace 1,500 pounds. So a typical car weighing roughly 3,000 pounds, well over a ton, it takes basically 2 feet of water to start floating it like a boat. We also have large hail that form in thunderstorms. The large hail tends to form where it's below freezing, obviously, because it's ice. Somewhere between probably 15,000 and 30,000 feet up is typically a good corridor of the thunderstorm where the hail actually forms. You can start out as a small little raindrop or a little ice pellet that gets held up in the thunderstorm by the updraft. It will gather more moisture on it. That could be the form of water vapor. It could be liquid water. It could be additional ice. They will kind of mesh together, and then they'll start to fall down. And they'll fall down into the rain area. The updraft will pick that little stone back up with all that liquid water on it, force it back up to the middle, the top part of the thunderstorm, where again it will freeze again. So all that liquid water that wasn't on it again gets frozen into a bigger ice chunk. And so that little cycle goes back and forth, up and down for several times until finally that hailstone is so heavy that it will now fall back down all the way to the ground. Those updrafts in these severe thunderstorms can be upwards of 50+ miles per hour, sometimes as high as 100 miles per hour. So the stronger the updraft, the larger the hail can be. I have highlighted there, watch out for March 25th, especially if you're in the Austin area. 3 out of the 4 largest hailstorms ever to hit the Austin area have all happened on a March 25th on the calendar. So just kind of an odd factoid there, but it makes you kind of think and wonder that, okay, I should maybe probably have a spot in my garage by March 25th every day to put my car. This is a picture and then a little radar clip there of the thunderstorm that produced, as we know it as of right now, a state record in Texas. April 28th, 2021, this stone was measured at 6.4 inches in diameter and weighed 1.26 pounds. I will tell you, those measurements and weight were taken 1 week after it fell. We did not know that someone had this hailstone until about 5 days after the thunderstorm. And by the time we got out to the house to be able to measure it officially, it was 7 days later. So that stone was bigger than that. However, we just don't know how big it was. The picture that you see with the person holding the hailstone was the size of it the day that it fell on April 28th. This was the group that actually flew out from South Carolina. We met them at the person's house, and we officially measured the hailstone there. They were from the Insurance Institute for Business and Home Safety. They do a lot of research on roofs and shingles, and so they will go around the United States getting sometimes these what they call gargantuan hailstones, doing measurements of them, density analysis, circumference, how much it weighs, just so they have a good database of how large hail happens and to what size it gets to. There is a good way and bad way to reporting hail as an official Skywarn storm spotter. The bad way is on the far left, taking images of hailstones with no actual reference in the image. Basically, if we get sent those images on the far left, I cannot tell with any certainty how big those hailstones are. Is it a big zoom in image or what? We just don't know. And so the best way to do it is to have some sort of measuring device in the image itself. That could be a measuring tape. It could be a ruler. On the very bottom there, you see a combination of a ruler, coin sizes, a golf ball, things like tennis balls, baseballs, and golf balls are all exact measurement sizes. So we know how big those are. Same thing with a ruler, obviously, and the same thing with coins. So even if you have a simple coin in your hand with the image of a hailstone, that will be much, much better than just the hailstone in your hand. Again, do we have a small hand or do you have a large hand? Just can't tell at that point. Moving on to microbursts and downbursts. These are events within very strong to severe thunderstorms that can bring significant wind down to the ground. Many times they are confused with damage that happens from a tornado, because literally winds of 70 to 80, 90, even 100-mile-per-hour winds from a microburst can cause very similar damage than what a weak tornado does. So most cases, when a tree is blown down, when there is roof damage, and people physically don't see what causes that, they just assume it was a tornado. And kind of the exact opposite is true. Microbursts are the most common severe wind that we get from thunderstorms. Tornadoes tend to be actually very, very rare. This is what a microburst looks like before it actually hits the ground. It is falling from the thunderstorm from tens of thousands of feet up in the air, a large batch, if you will, of wind, colder air, and rain all headed down toward the ground. This is what we would be calling a wet microburst because it has a lot of rain with it. Areas in the western United States that tend to be very dry and have low humidity have a lot of what we call dry microbursts. They get the wind from the thunderstorm, but they don't necessarily get a lot of the rain. When it impacts the ground, it will start to spread out in all directions. At this point, we'll actually call it thunderstorm straight line winds because it's literally then hitting and going out in a straight line. From a distance, we actually have something called a rain foot. It actually looks like a small foot because it's actually, the wind is now hitting the ground and now spreading sideways. And so it does tend to look then like a foot. So again, these can be upwards of maybe 50, 60 mile per hour are the common microbursts. There are some that are lower than that, like in the 30, 40, and 50 mile per hour range that don't have significant damage. But once it gets above that 60 miles per hour, you'll start to see some pretty significant damage. These are some pictures from microburst damage from around South Central Texas, where we have anywhere from trees uprooted to trees snapped, power poles snapped, and even buses or high profile vehicles like this camper that you see in the middle was actually tipped over. So again, we have registered winds well over 100 miles per hour with microbursts before. And that, of course, as you can imagine, causes massive widespread tree damage and roof damage in neighborhoods and portions of, let's say, a whole county. Things that are not tied down outside can go flying. And one of those common items that goes flying are actually trampolines. So we have image and a video clip of a trampoline crossing a driveway. And then on the far right, we actually have an image of a trampoline that was stuck into the side of a house. And then we come to funnel clouds and tornadoes. By definition, a funnel cloud is a rotating column of air from a rain shower or a thunderstorm, not in contact with the ground. As soon as it becomes a big enough funnel that makes it all the way down to the ground, that's when it'll officially be called a tornado. So I don't know, when I've seen this several times where you're reading a newspaper article or something online, they say a funnel cloud caused this damage. Technically, if the funnel cloud is causing damage near the ground or on the ground, that is an actual tornado. So where we have actually had tornadoes in the past are plotted on this map. Every state in the United States has actually had a tornado. But this is a plot where you can really kind of see where the majority of them are. And the answer is basically east of the Rocky Mountains, where a lot of times it is hot and humid, especially during the warm season months. So the length of the line actually shows you the track of the tornado and how long the track is. Notice some of those lines across Alabama and Mississippi, the southeast United States, on the northern Gulf Coast. Some of those tracks are upwards of 50 to 75 miles and cross multiple states. So those are those catastrophic sort of tornado emergencies and those large tornado outbreaks that we've actually had in the past. I will tell you too, like in Texas, there's a lot of areas that it doesn't seem to ever have had a tornado before. That's false. What we're seeing here are verified, seen, or documented tornadoes. Texas, of course, has a lot of ranch land, huge ranches, tens of thousands of acre ranches, that even if a tornado goes through that ranch, there may not be any evidence that that actually occurred. We need visual evidence to actually document it officially. So there's been a lot more tornadoes that have ever been documented. It's just that you need people to see them and to report them. So as we talk about tornadoes, this is that San Antonio event that happened last October. You're seeing a trampoline get thrown through the air. Like I said, trampolines get thrown a lot. This tornado was on the ground upwards of 15 minutes. It's crossing right behind the botanical gardens of San Antonio. This video was taken off of Highway 281, just north of downtown. Believe it or not, so this was on a weekday morning around, I believe, 8:30 a.m., something like that, between 8 and 9 a.m. So during rush hour of a weekday. Zero reports to the National Weather Service about a tornado on the ground. So we talk about, we've done this training, Skywarn training for decades, especially around the San Antonio area. We have probably well over 5,000 people have taken our trainings, yet nobody called the National Weather Service to report a tornado on the ground. Part of that is because this tornado was so weak, many times, like right now in the video clip, it doesn't look like a tornado. There is no funnel. All you see is all this kind of debris kind of flying around. There's only a few instances in the entire 15-minute track where we think it was technically visible with like a funnel. And obviously, if you're a really good trained weather spotter, you're looking at this video and you're knowing that's a tornado just from all the flying debris that's getting kicked up. But people in rush hour, they're driving, they're paying attention to what's in front of them, they just didn't see anything. This also did not happen with a thunderstorm. This was from a rain shower. So there was not a tornado warning out. There was not a tornado watch out. Nobody was thinking about severe weather this morning. That's a typical tornado, believe it. We have an enhanced Fujita scale, EF scale that we use. This is an EF0. Now the EF1s get all the way up to 110 miles per hour. So yeah, you can have some significant damage and you can get some fatalities from weak tornadoes. But they are very difficult to detect on Doppler radar and they're very hard to confirm because of that. Very commonly, they may be on the ground only for 1 or 2 minutes. This one was kind of rare in that it was on the ground for about 15 minutes, but there were some spots in the track that we could not find any damage. So it kind of lifted in several different portions of the track across San Antonio. As we go higher up in enhanced Fujita scale or EF scale, these are now 2 and 3 scale tornadoes. They tend to be larger, not all the time. You cannot technically see the size, the width of a tornado and tell that it's a very large and damaging tornado. Maybe visually large, but technically you need to look at the damage that had occurred to get the estimate of wind. And the estimate of wind speed is what gets it the EF scale that we give it. So this is a video clip. This is out also on March 21st of 2022. I think just outside of Elgin, Texas, so east of Austin area. And again, a lot of flying debris, not a great funnel visible with this, but this manufactured home is about to get destroyed right there. It tips over. are typically our first fatalities from tornadoes show up in trailer parks, manufactured homes, mobile homes, objects that can be thrown very easily. A house just got hit right there. You can see all the pink fly out of it. That's all the insulation from the attic. Whereas the house was able to stay on its foundation. And so the safest places to go, which we'll talk about at the very end, the safest buildings to be in are buildings that are secured down to the ground. And typically the typical house, the typical building, even business, basically has a slab of concrete and those walls are bolted down into the concrete. Those are the safest locations. This is an image of a house in Round Rock, Texas. I scaled the tornado as an EF2 at this point because the whole upstairs of this house and the whole roof was actually swept off. Not every house or not every portion of a tornado track is the same strength. The tornado will get weak, it'll get stronger, maybe it'll go back through a weakening phase, and then it'll get stronger, then finally it'll totally dissipate. So if we call the tornado an EF2, like in this case, that doesn't mean it was an EF2 the entire track, because it does have to start very, very small, and it's very weak when it first initially starts. So we label the tornado at its peak intensity. So these EF2 and EF3 tornadoes can be upwards of 165 miles per hour. And then they can have a very long lifespan. In fact, this tornado for the Round Rock area was on the ground for well over 30 miles. As we go up into higher scale of tornadoes, EF4 and EF5s, notice, again, middle part of the country. In the western United States, hardly any tornadoes are strong, but the heartland, right? The southern plains, the central plains, northern plains, the Midwest, the upper Midwest, the upper Mississippi Valley, lower Mississippi Valley, are where the majority of all of these larger tornadoes have occurred. And then particularly EF5 tornadoes. So I guess the one question is, well, then where were they there in Texas? Well, the one dot closest to South Central Texas is in fact our Gerald tornado, Gerald, Texas tornado back in May of 1997. But overall in the United States since 1950, not a lot of EF5s. In fact, our Gerald tornado in Texas is the last EF5 tornado to occur in Texas. So we've gone well over 25 years without an EF5 tornado in the state of Texas. These are images from Gerald. The top left image is from Interstate 35 as it was coming and moving southwest along Interstate 35. And then the other image there was actually, I believe, when it was going through Cedar Park, where it weakened. It was still a strong tornado, hit an Albertsons supermarket, and then continued on southwest all the way down toward Lake Travis, where another fatality occurred. I believe 28 fatalities occurred around the Gerald area initially with the EF5 tornado. Like I said, it had a long track and it kind of skipped, it kind of weakened, and then it strengthened again all the way down by Lake Travis. So these tornadoes produce winds of in excess of 200 miles per hour when they reach the EF5 scale. They are catastrophic events that wipe out towns, wipe out neighborhoods, mass casualty events. The image on the far left was a well-built house in Gerald, Texas, and you can see it is obliterated, and there is basically nothing left from that. The ground is brown from all the scouring of the earth. Asphalt is peeled up off the highways. Trees are debarked, and stumps are basically left. It is catastrophic sort of wind damage, and not many buildings can withstand that amount of wind. Even if we tell you to be going, to the bathroom, in the bathtub, cover yourself with a mattress, in that tornado, you are still likely a fatality. You have to be underground or in a concrete bunker or a concrete shelter typically to survive something at this magnitude. So our second part of the training is actually how thunderstorms form and how to spot them visually. What sort of things do you look for? So to get a thunderstorm to even form, we need ingredients. We need moisture, instability, and then lift. So imagine like a cooking recipe, right? These things have to be present in order for us to get even a general or ordinary thunderstorm. And that's what we're going to talk about first. Those garden variety, summertime-like thunderstorms that produce brief heavy rains, and by the time it's headed to your house, it dies out. With the infamous dome, right, that sits over your house that makes thunderstorms split, right? We hear that all the time. That's just the nature of thunderstorms. And so when they start out in this developing cumulus stage, where there is mainly just one updraft and there is nothing falling yet as a downdraft. So this is just all that warm fuel that's going vertically. So these can build up to 15 to 20,000 feet rather rapidly. And then in about another 20 minutes or so, it'll get even higher, maybe into that 30 or 40,000 foot range, and it will start to rain. So when it starts to rain, that will not only cause cool air to come down to the ground, but it'll actually drag cold air down with it too. So you have the red arrows representing the updraft, or all the fuel, the warm, humid air rising, and you have all the blue arrows coming down, which are part of the downdraft, or what I'll call now the exhaust of the thunderstorm. This is the mature phase of the thunderstorm, where you have both the updraft and the downdraft. Now, as I mentioned, the warm, humid air is the fuel for the thunderstorm. So if colder air comes down from the thunderstorm and replaces that, well, there's no gas that's left. There's no fuel for the thunderstorm to keep going. And in fact, that's kind of what happens then. I have this kind of represented as a water fountain on a calm day with not a lot of wind. As the rain forms, it comes down literally on top of the updraft. So it rains itself out. Like I said, it needs warm, humid air for fuel, but if all the cold air comes down and pushes away all that warm, humid air, well, there's nothing left for it to gain strength, or there's no gas left for the engine. And so literally that's what happens after raining for about 20 minutes. There's no more fuel to use. There's no more warm, humid air around to use as the fuel for the engine. And so the engine dies. The thunderstorm dies. And all you're left with a sprinkle. Maybe there's some cooler temperatures around, and that's it. So somebody got lucky and got that 20 minutes worth of rain, and most other people are unlucky and do not get the rain at all. They just saw it, they smelled it, maybe they got the gusty winds from it and the cooler temperatures, but they didn't get the actual precipitation. So to get a severe thunderstorm to form, a thunderstorm that will last much longer than 1 hour, we need to have another ingredient. We call that ingredient wind shear. Most commonly, if you watch TV or talking to the meteorologist, a point where we know wind shear will be over us is if the jet stream is over us. The jet stream is a river of air that goes around the globe in different locations, generally in our area from west to east across the United States. And if it dips really low across Mexico, that column of air, that river of air that is around 30,000 feet or so, that's kind of where the low pressure centers will travel. So it's kind of like the highway where the storm systems will come across Texas. Well, that wind shear means that the winds are very, very strong at the highest levels of the atmosphere, like where the airplanes fly at that 30,000 foot level. And a good example of a strong jet stream or strong wind shear at that level would be, let's say, maybe 100-mile-per-hour wind that's blowing from west to east across the United States, or in this case, maybe from southwest into Mexico across Texas, would be what that wind shear would be. That stronger wind aloft, as I mentioned, 100-mile-per-hour wind does something kind of special to the thunderstorm. Instead of the thunderstorm forming vertically, the wind is so strong at the mid, where we show the 50-mile-per-hour wind, and the 100-mile-per-hour wind, let's say again at that 30,000 foot level, the whole thunderstorm gets tilted over. It's literally pushed over on its side from the strong wind. Another thing that happens too is that when it does start to rain, the rain doesn't fall straight down like I had depicted on some of the other weaker thunderstorms that I showed a couple of slides ago. The wind is so strong it actually pushes the wind, and it pushes the raindrops and hailstones out of the actual thunderstorm. Very reminiscent the same way if you try to water your grass with a sprinkler on a windy day, or if you do go and look at a water fountain and what happens on a windy day. The raindrops are blown, and sometimes blown miles downwind. So it's very common sometimes I'll be driving and I'm using the windshield wipers and I can't see the thunderstorm where the rain is coming from. And it's literally because the wind is blowing that raindrop out of the thunderstorm. Well, what I've done by blowing the raindrops out of the thunderstorm and downwind, as depicted in this graphic, there is a distance between the updraft and downdraft now. They don't happen on top of each other like they do on the garden variety thunderstorm, on the weaker thunderstorms. They're now separated miles apart. So the fuel area where the updraft is keeps going. The downdraft, or the exhaust of the thunderstorm, keeps going. Well, I've now described a perfect engine. where you have unlimited fuel and you have a good exhaust system. What happens? That engine can just keep running and running and running. And so that's why when you have all these ingredients, especially this wind shear ingredient now for a thunderstorm or an outbreak of thunderstorms, these thunderstorms can now last hours on end. Particular thunderstorms, single thunderstorms. I've worked weather events where we've had thunderstorms develop in northern Mexico, cross the Rio Grande, cross the hill country, hit Austin with big time hail and possibly even tornadoes. And then by the time my 8-hour shift is going, the thunderstorm is still moving. It's now gone into the Houston jurisdiction and affecting like Bryan College Station. They can be that perfectly balanced of an engine that they just don't stop. And they don't stop until they get into an area where the ingredients are not as good. So this is what I was kind of describing on a windy day. Look how the fountain, all that rain, if you will, is getting blown downwind from where the actual updraft is, right? So just gives you a visual of kind of what is happening in these thunderstorms on days where we actually have wind shear over us. So for the key of forecasting severe thunderstorms is where is that wind shear going to be? And how much wind shear or how much wind speed do you need in the upper levels of the atmosphere to cause thunderstorms to get into this great balance of updraft and downdraft or fuel and exhaust? And so this is where we kind of divide up now our types of thunderstorms. The thunderstorms that form in a very common atmosphere, the ones that we have in the summertime all the time, are called single cell thunderstorms and multi-cell thunderstorms. These are typically not severe weather producers. Yes, you could get some pea-sized hail out of this, or you could get some gusty winds to 40 miles per hour. But these are the thunderstorms that typically only last an hour or a couple of hours in the case of a multi-cell. Yes, you could have some pockets of heavy rain. You could get a little bit of isolated flooding, but not really big time hail events and not really big tornado events. Those are kind of safe for when we have a lot of wind shear. And there's two different types of thunderstorms we'll describe, and those are called squall lines and supercell thunderstorms. So as the instability of the atmosphere or the potential energy increases and the wind shear increases, so does the threat for severe weather. So again, those are the keys. Those are the variables and the ingredients that we are looking for when we are trying to figure out, is it going to be a regular thunderstorm day or is it going to be a severe thunderstorm day? As a storm spotter, or anybody that's outside a lot of times during severe thunderstorms or thunderstorms in general, a lot of people like to look at them. And what you can do is start to really kind of notice what I call the camera factor. How significant does it look? How beautiful does it look? This case and the next case right here are cases where it is, I think, a gorgeous looking thunderstorm, something that maybe I've only seen maybe 2 or 3 times in my lifetime, especially this image, where this crisp edge that you see, the cauliflower look, indicates a very, very strong updraft. So in cases where we have very, very weak thunderstorms, it is very wispy looking. It is very cotton ball looking. It doesn't have the nice crisp edge and a cauliflower popcorn sort of look. Typically, these strong to severe thunderstorms also have very good anvils on them. Those are the tops of the thunderstorms that flatten out. Now they flatten out because there are different layers of the atmosphere. And the bottom layer of the atmosphere is called the troposphere. And when a thunderstorm builds vertically and gets to that 40 or 50,000 foot level, well, that's where the troposphere stops. And the next level, called the stratosphere, starts. Thunderstorms don't go into the stratosphere. They don't build up there because it's a very stable layer of our atmosphere. But there are a couple of instances that sometimes you may see where in fact the thunderstorm does build into the stratosphere. And in fact, we're seeing one on the screen here. This is called an overshooting top. It is overshooting the anvil. So what this indicates is that the updraft is so strong, in this case, maybe upwards of maybe a 75 mile per hour vertically driven updraft, is that it punches into the stratosphere. So it doesn't care that it's not supposed to go up there. It has so much momentum that it can't stop. We will see these a lot of times on satellite images, especially later in the day as the sun starts to set. That bulge on top, or that overshooting top, will actually cast a shadow on satellite images. So typically we don't have an overshooting top as a reporting feature for a Skywarn spotter. Besides, you typically have to be nearly probably 50 to 100 miles away from it to be able to see it. but it is a nice visual clue that you actually have a very, very strong updraft and likely a very strong or severe thunderstorm. So next, we're going to talk about where to look for a tornado formation. Now, hardly any thunderstorms produce tornadoes. They're very rare. But in the case of severe thunderstorms and well-organized thunderstorms, there's a very common place to look when it comes to the potential beginning part of a tornado, which we call typically a wall cloud or a funnel cloud. And that area is called the rain-free base. It is the base of the thunderstorm where it is not raining, because that is where the updraft is. If wind is blowing vertically or the updraft at, let's say, 50 miles per hour, a little tiny raindrop is not going to have enough weight to make it through that 50 miles per hour of a wind blowing vertically. And so that indicates where the updraft is. So anywhere underneath a large thunderstorm where there is no rain falling, that is the updraft. The downdraft, again, is further downwind, as that wind shear carries the raindrops and hailstones and everything else further off to the right, or typically further to the east, depending on where that thunderstorm is moving. But this updraft area is going to be the key place to look for beginning rotation, like I said, a wall cloud, which we'll talk about next, a funnel, and then possibly even a tornado. So on the far left are really good images of what we consider wall clouds. This is under the rain-free base, and it could be that it hasn't even started raining yet in this case, but most likely if the picture would extend off to the right a little bit, you'd probably see the rain shield coming down. But this lowering, this isn't some just free-floating sort of cloud. This is actually part of the bottom of the cloud, but it comes down lower than the rest of them. This is where we would probably see some rotation, and it would be slow rotation. It's not going to be very violent looking, but a slow, methodical sort of spin counterclockwise is what you would typically see for a wall cloud. Now, I will tell you that, being in South Central Texas, we are not in Oklahoma. We're not in Kansas, where you can typically see 50 to plus miles, off into the horizon. We have trees, we have houses, we have buildings, we have everything else. So spotting in an urban area is extremely difficult. Spotting in a place where you have hills is very difficult for obvious reasons. You can't see past the horizon more than maybe sometimes a mile or so. On the far right-hand side is a picture taken down from the Corpus Christi area, and this is a wall cloud that is a little bit more ragged looking, and that's the case. When you have a lot of humidity like we have in this region of Texas, everything is a little bit more ragged. Everything isn't as classic looking as a textbook that you see with storm chasers and everything in Oklahoma and Kansas, where it's a little bit drier and easier to see some things. But do look for rotation, and I said especially counterclockwise is typically what you would see. If that's the case, then that would be called a rotating wall cloud. And that would have to watch very, very closely, because that rotation could shrink down and become a funnel. And then if everything is perfect, that funnel could shrink down and extend all the way to the ground. And then you'd officially have a tornado on. This image on the left, again, a very good image of a strong to severe thunderstorm, a very, very large rain-free base. The arrow is there pointing to the wall cloud, or the lowering to that rain-free base, and all the rain and hail is being blown off way off to the right and coming down with those down arrows. Now, where that rain and hail is coming down, along with that colder air, that area where the downdraft is sometimes will produce a very scary-looking cloud called a shelf cloud. And that's what the image is showing on the far right. It is ominous looking. There's no doubt about it. But all it is actually showing you is that that's where the downdraft is, and that rush of cold air has hit the ground and is now spreading towards you. So it is true that yes, once that shelf cloud passes by you, the storm is likely probably approaching, which means, yeah, you may get some rain and you may get some hail and some damaging winds, and maybe eventually you'll get a funnel cloud, tornado, or maybe you don't. But very little as far as tornado formation happens right along that shelf cloud. If you're in the colder air of the thunderstorm, you're typically not in the good area where you would actually see a tornado. The tornado tends to be in that updraft region, where again, that would be more of the warm sector, or the area where it's still warm around that thunderstorm. But the shelf cloud can be scary. A lot of people see a low-hanging cloud near a thunderstorm and they immediately think funnel or tornado, and that's just not the case. In describing the two different types of severe thunderstorms, one of them is called a squall line. These tend to happen a little bit more in the seasons where we're changing, so spring and fall where you have cold fronts coming, they'll tend to align themselves on cold fronts or other sort of boundaries. They tend to be very long sometimes, to where they can be hundreds of miles long, stretching from, gosh, the Central Plains all the way down through all of Texas, like in this example that you're seeing. They tend to move very quickly. These lines of storms can be upwards of 40, 50, 60 mile per hour movement. And so that will typically bring a lot of damaging wind with it. Not all the time, but typically the faster that thunderstorm is moving, the more likely that you're going to get some damaging winds with it. These long lines and sometimes skinny lines of thunderstorms, they're not great hail producers. You may get some sort of smaller hail, but you're not usually getting baseball size or softball size hail from a squall line. We're typically concentrating our efforts in our warnings to wind damage. There can also be some isolated smaller tornadoes right along the leading edge. We call those QLCS events, quasi-linear, basically a line of thunderstorms, and you can get some really, really small spin-up tornadoes. They can be damaging, but they tend to be in that EF0, EF1, and EF2 range for the most part. By far, the most damaging thunderstorms that we get are supercell thunderstorms. They are commonly kind of seen on radar with a hook, and you'll see that in the bottom left image there, where there's a nice hook. That hook, or the little pin there in the middle of the hook, is typically where, if there is a tornado on the ground or forming, that's where it would be. Just because you have a hook on radar does not mean you have a tornado on the ground. All that indicates is that you have a rotating updraft, which we call a mesocyclone. And so that is the favorite area to look, especially visually if you're a spotter or somewhere near the ground. That's typically where we would want people to look at to see if they do see a wall cloud, or if they do see evidence of a tornado or a funnel. These supercells have everything we talked about: the cauliflower look, the overshooting top, the good anvil, and the large, very, very large rain-free base. So they can last for hours, like I mentioned. I've watched ones that have formed off of Mexico and have come all the way across our jurisdiction. The Hondo hailstone that we showed, that was a supercell thunderstorm that came out of Mexico and came right along Highway 90 there in Hondo, Texas, and then eventually actually got into Bexar County. So they form a very, very strong wind shear. So again, the forecasting end of this is that if you know you're going to have a lot of wind in the upper levels of the atmosphere, and you have the instability, and you have the moisture, and you have all the ingredients, then you're setting the stage for possibly getting some supercells to develop. And as soon as we hear the word supercells, we should be thinking potential for large hail, and then sometimes even potential for getting the tornadoes. Depending on where you are in relation to the storm is going to determine on what you see, or if you see anything at all. If you're in a bad position, like up here by the blue, this arrow up here, I'm going to circle it. So if you're in this location right here, and that thunderstorm is generally moving in this direction, you'll probably see that shelf cloud, and you'll get a whole bunch of rain and a whole bunch of wind, and that's maybe all you're going to see, because visually it's going to be raining so hard you can't see anything, even if there is a tornado coming. The difference is that if, let's say, you're down maybe in this position, and again the storm is moving from southwest to northeast, which is the most common way thunderstorms produce, not all, but common, then you would have a very, very good visual. You're not going to be obscured by rain, because the rain and the thunderstorm is still off to your north, and it's going to be passing to where that hook area, where the inflow, the updraft, kind of shown in that red area there, you're going to have really, really good visual. So in a perfect world, yes, you would always be kind of south of a storm like this, where you can have really good visual. Well, the problem is that, again, we don't want you jumping in a car and chasing these things down. We don't want you jumping in a car and purposely getting in the path of one of these. So sometimes you're just not going to be in great position to visually see what we want you to see. And if that's the case, well, then you're not going to be spotting that day. But if you do happen to see something outside, that's where we're going to want you to kind of call. So again, not all thunderstorms move from southwest to northeast. The good example here is the Gerald tornado, which moved northeast to southwest down Interstate 35. Another good example of a supercell thunderstorm that did not produce a tornado. Again, the majority of supercells do not produce tornadoes. They do produce severe weather in very, very large damaging hail and very large microburst winds. But a small fraction of them actually produce tornadoes. Trying to decide on which supercell is going to produce a tornado and which ones are just going to be hail producers is still a very active science, I guess I'll say. This is an example of our Del Rio radar out by Brackettville, is where it technically is, and that was a bad day. That was 100-mile-per-hour straight line winds, along with, I think it was like baseball-sized hail, and did significant damage to our Doppler radar out there. It did not produce a tornado, having known. So here's a couple of quiz questions, basically, where we're talking about are these tornadoes or funnel cloud images? And the good answer is that these are and would be reported as tornadoes because of this. So that is debris, and this is debris. So this is evidence that even though you don't see the funnel going all the way down to the ground, it is in contact with the ground. So this is one of these where the tornado is actually partially invisible. Now, eventually it may kick up and suck up enough dust and dirt and everything else that maybe you may see that funnel going from the ground all the way up to the cloud. But in cases like this, maybe you don't. And these, again, are kind of good examples. That one drone video that I showed of the tornado near Elgin, you saw all the flying debris around, but actually you didn't see this very textbook sort of a funnel. And so it just depends on the atmosphere, depends on where you're at, and whether or not the funnel wants to form all the way down to the ground or not. Sometimes the tornado can be totally what we call rain wrapped. The rain with the mesocyclone will wrap all the way around the tornado, and basically the tornado becomes obscured, meaning you can't see it, meaning you're just driving down the road and you think you're driving into a big rainstorm. In fact, there could be a very, very large tornado in amongst all of that. So you have to be careful about those sort of tornadoes. Again, we typically, before the day starts, we don't know if we're going to get rain-wrapped tornadoes or not. But it's much more common in the southeast United States, this part of Texas, as you have higher humidities, you have higher rain-producing thunderstorms. It's a higher likelihood of getting rain-wrapped tornadoes as opposed to maybe if you're seeing tornadoes in eastern Colorado or Kansas or Oklahoma, where it tends to be a little bit drier and the thunderstorms don't produce as much rainfall. So there's going to be some tricks, and the thunderstorms are going to be trying to play some tricks on you, especially underneath the thunderstorms. Where the rain-cooled air is, a lot of times you will see very ominously black and strangely shaped clouds called scud clouds. These are cloud fragments. These form because of the rain-cooled air that happens underneath thunderstorms and underneath that exhaust area of the thunderstorm. Don't get fooled by, well, the Weather Service has issued a tornado warning. I'm going to go outside and try to see it. And if you see something just kind of hanging there that is kind of a little bit of the shape of a tornado, you're going to say, oh yes, I see that tornado. It may not even be a tornado. These clouds, these scud clouds, do not rotate about a vertical axis like a tornado does. These may be more on a rolling sort of a thing. Again, that cold air comes down to the ground, it hits the ground, and then it starts to spread out, which kind of induces almost like a horizontal roll a little bit. So these clouds will dance around a bit. They may look scary, but they will not have that nice funnel shape, and they will not be rotating counterclockwise about a vertical axis. They're just low-hanging clouds at this point. And they're dark, low-hanging clouds, probably near a severe thunderstorm, and that's all they are. So where should you go in a tornado or a high wind scenario? The best thing to do is find an interior bathroom of your house or apartment or condo or wherever you live, or a closet on the lowest floor, or if you have a safe room. Now, most of us do not have safe rooms built into our houses. Those are concrete structures that they build specifically for tornadoes. You see these much more commonly in the middle part of the country, Tornado Alley, I guess I'll call it, southeast United States, where they'll have some half-buried sort of bunkers underground. In this part of Texas, it's very rare to come across basements, and it's very rare to come across tornado shelters in big urban areas. So go downstairs, find an area that's in the middle part of your house where you have multiple walls protecting you. That's typically in a hallway closet. Again, a half bathroom where there is no window. Windows shatter with flying debris, so you don't want to be in a room that has a window particularly. Now, I understand there are some buildings and there's some houses that just don't have an interior room. Well, then what you're going to have to do is you're going to have to make the best of it by going downstairs and being in a room where you can push the mattress on top of you. Get into a coat closet that has a bunch of soft material. Put a bicycle helmet on, whatever you have to do if you don't have that interior room at your disposal. The reason why you want to get away from exterior walls are like from these images here. I have an Austin tornado in January of 2012. I have a February tornado in San Antonio in 2017. Both of those were rated as EF1 tornadoes, those images. So even at a low-end tornado, an EF1, there are still 2x4s and larger timber and lumber that are skewering through the exterior wall. That middle picture there from Alabama, that was an EF3 tornado, and you can see how that could become very, very deadly, right? Luckily, that person was not in bed in his master bedroom, but that is the type of damage that can occur from those higher end tornadoes in particular. The flying debris is typically what kills people in tornadoes. And so that's why not being outside, not being in a vehicle, not being in an exterior walled room are the most important ways to try to survive. The worst places to be in a tornado are places that can get moved. Vehicles, cars, buses, travel trailers, mobile homes. They have the word travel in it and they have the word mobile in it, which means they're lightweight and they're designed to move. To be honest, even if you have a manufactured home that has tie downs, yes, those tie downs can save you with some wind. They're rated, I think, over 100 miles per hour, but as you saw in that one video clip, all it takes is one roll, and that typically the manufactured home or travel trailer will start to literally disintegrate as it rolls over once. And that bottom right image of the cars stopped on the highway, don't do that. You're blocking traffic. You're blocking traffic and vehicles from exiting to be able to get to a shelter. So I know a lot of people just stop underneath the underpass because they don't want their car to get hailed on. But if there is a tornado associated with that severe thunderstorm, basically everybody back behind you is a sitting duck because now they have no way of getting off the highway to get off and either going the wrong direction or the other direction, or even making it to a gas station and sheltering in the cooler, which is a much better place to be than your vehicle on the road. So be very, very aware of that. Okay, it comes down to this. A 1-800 number. This is an unlisted phone number. Please do not give this out. Don't post it on social media. This is a protected phone number that we give only to our trained weather spotters. It is a very simple phone number in that we want you to produce a very, very simple report. You don't need to be on the phone for us for 5 minutes. I'm talking about a 10-second phone call where you give us where you're at, your location, and get as specific as possible, cross streets, an actual address. Okay, you can't just say I'm in Austin. Okay, Austin is too big. Give us some cross streets, a highway address, something. What are you seeing, or what's happening to you? Are you getting hail right now? Did you just come across some wind damage, a tree blown down? And then try to either tell us what time it is currently or what time you saw it. We love real-time reports when it's happening right now. However, we also know that a lot of times we get them post-event, meaning that you call us or can call us even hours after the event reporting the damage that you saw, or maybe a family member called you because you weren't home at the time and you got hail at the house. So it sometimes takes us days to go back and find verification or look to see what happened in an area. So real-time reports are the best, but delayed reports are just as good for us in that we still try to verify these thunderstorms and find out exactly what happened. So what do we want you to call about? Hail of any size. Even though the hail the size of dimes is not 1 inch in diameter and is what we call sub-severe hail. If you call us with hail of any size, it allows us to look at the radar and compare it to what we're getting at the ground. So it gives us a literally a real-time calibration of this is what the storm looks like on radar, this is the hail that we're getting. That way, if the storm looks bigger on radar or increases in strength on radar, we know there's a fairly good shot that the hail is going to get bigger than what you just reported. So hail of any size, any sort of significant wind damage, the big tree branches down, trees uprooted, flooding or extreme rainfall amounts, any sort of tornado, any sort of rotation underneath that rain-free base, any sort of funnel cloud report. And we know that, yes, that rotation underneath that thunderstorm in funnel clouds is very tricky to report, especially in urban areas. However, I would say err on the side of caution and call us and let us know what you're seeing. It's very likely that we can take your location, look at it, radar, and to kind of see if you're even in a favored area to be getting some rotation. Or maybe we've been tracking a mesocyclone for the longest time, and finally you're calling and you're actually seeing some rotation that is verifying, okay, yeah, maybe we need to put out a tornado warning because that rotation is getting tighter over the past couple of minutes. And then finally, also winter precipitation. Freezing rain, sleet, snow totals are all very important for us, especially as we're getting into the winter season. If you like to be on X and you want to report instead of a phone call, you can use the hashtag NWS spotter. We filter those out and we'll be kind of searching through social media looking for reports. The caveat there is make sure you're giving us all the information we need. Just don't take a screen capture or take a picture of a hailstone in your hand and hashtag NWS spotter. I don't know what time it happened. I don't know where you were, and I probably don't know what size it is because you just have a picture of hail in your hand. So you need to go through all the aspects of the reporting. What time was it? Where did it occur? And what event was it? If you're going to report via social media. I will tell you, with anything of significance like a tornado or rotation underneath a thunderstorm, I would definitely call us and let us know so we can talk you through it. We can find out which direction you're looking and everything. If you want to report just some hail, it's hail that fell 10 minutes ago and it was a, quarter size hail or golf ball size hail, doing it via social media is fine. But of course, we always encourage people to call us. That's why we're here. And then finally, to wrap it up, I wanted to talk about the significance of taking rainfall reports. We had that as a reportable thing there for storm spotters, and we talked about how deadly this area was because of flash flooding. So this kind of brings this all into play. There is a group called COPARAZ that is a nonprofit that started in Colorado, which is a rain, hail, and snow network. It is a network that started a couple decades ago of a web-based reporting website. So people could go in, report how much snow fell on a public web page. They've expanded it nationwide to include rain and hail also. We use it obviously more as a rainfall reporting just because we don't get a lot of snow. The website is coparaz.org. What we want people to do is to join. If you have a rain gauge, if you have a place in your yard to put a rain gauge that isn't, if your backyard is full of trees, okay, don't put a rain gauge out there. It's not going to do good. But if you've got an area of your house or your yard or ranch, and there's a good spot to put a rain gauge out, and get a good one, and then put that data online so everybody can use that data. Once you join, you need to buy one of their rain gauges because they don't want rain gauges of all different shapes and sizes and accuracies. The rain gauge that they sell on their website is about a $40 rain gauge. It holds 11 inches of rain and measures in 1/100th increments. So they don't even want you to use the automated weather station rain gauges. Those can underestimate and even overestimate time, especially if they're not calibrated. These rain gauges are manually read, means you got to go outside to look at it, and they want you to measure the rainfall and report it basically once per day. You can report via their webpage, like this is a screen capture of my rain gauge, Comal County number 64, or what I like to do is report via their app. So they have apps on all the different, on the Apple platform and also the Android platform. And so this is what I do every morning. I will come on and report, even on days where there is zeros. Zeros become very important rainfall reports, believe it or not. And that's because, especially like right now, when we've gone so long without significant rain here in South Central Texas, we're starting to creep into the drought again. Well, when we go and do our weekly drought severity index sort of conference calls, we will be looking at COPRA's data across the counties to see at what level of drought severity maybe we need to increase or decrease. So people use this data. Don't think that you take the time to go outside, get the rain gauge, make the measurement and report. Don't think that somebody isn't looking at that. We are looking at that information daily, and anybody that has access to this website, which is everybody, can look at your data. Your name is not given on the actual website for the general public to see, but your location of your rain gauge is mapped out. So this is a screen capture from the United States on one particular day earlier this year on March 1st. All the dots represent people that logged into the website or on the app and put in their rainfall totals. All of this is archived daily, all the way back 15 plus years. So you can pick a day in the last 15 plus years, zoom into whatever state you want, and see what the rainfall totals were from someone that probably reported in and around that area. This is a screen capture from one of our famous flash floods. This is the Halloween event in 2015. These red dots represent rainfall that was in excess of 7 inches. If you look at some of the numbers along Interstate 35, especially around Kyle, there's a 15.63. I'll try to circle it here, and even a 12.32 in there, right? So so those are some overflowed rain gauges. Now, those people were very proactive. They were actually calling us during the actual event and letting us know how much rain was falling. So then they basically, the rain gauge did not overflow because of that, and they were able to add up all those different rainfall totals for us. So we tend to see that some of these COPRA's observers are some of our best weather spotters because they're into the weather and they check it daily. And so we've kind of gone back and looked at our Skywarn training now, and now we purposely kind of talk a lot about COPRA's because there is so much crossover between reporting and the dedication and people that are interested in weather, etc. And so when you actually go into anybody's rain data, you can just explore and you can see how much rain fell. So this is my station. You can go into the Data Explorer button there, and this was a screen capture back at the end of March. I had 10 inches of rain, total 9.73. I will tell you right now, I'm over 30 inches of rain for the year. But again, hasn't really rained the last 2 months. I was looking really good at the end of July, and now all of a sudden my grass is yet brown again because we're going through one of these what we call flash droughts, where we're just has not rained in now a couple of months, it seems like. So I encourage you, not only, well, I'm encouraged because you're joining tonight as a Skywarn storm spotter, but also if you have a rain gauge, get a better one and get that data online so the world can see it. And that's using the COPRA's website like that. So with that, we have come to the end